Hello everyone. Today's video is going to be a review of the 3D printer that I'm using. I've had a couple of questions about it, what setup I'm using to print my vapor blast guns and accessories. So what I got here is a Creality. It's a CR10S Pro and it's the version 2. The reason that I decided to go with this particular one is it already comes with a lot of the upgrades that you would normally make to an entry level printer already included. And that was appealing to me because I wasn't sure which upgrades were going to be the most important ones to make. And for me, it was more of a question of convenience than the difference in cost, really. And a couple of things that I really liked about this printer that I did not see with many of the others is let's start with the bottom. Okay, the rail system for the bed it's a dual rail system. So you got two rails and then the wheels run up and down on these dual rails. So because you have the dual rails, you don't have the possibility of the side to side wobbling of the build plate. A lot of the entry level units, they'll bring one bar in the center and the wheels ride up along it up and down, which is okay if you're printing things primarily in the center. But once you start getting off into the edges, then it becomes more important that this is a very stable surface. That was one of the things. Another thing that I really liked about this particular one is on the Z axis, which is the portion that moves up and down. The gantry support uses dual threaded rods, and there's two stepper motors, one on each side. This makes this gantry setup more stable. Many of the other models that Creality produces don't use a second threaded rod or stepper motor. They just simply have the gantry with the wheels across both bars, all controlled by one stepper motor. And if the print bed is a shorter print bed, it may not be as big of a deal because once you start getting to a certain level, since the bed is so short, not as wide, you're not going to have any kind of sagging problems. Well, that was one of the reasons that initially was thinking about getting this particular one. Another thing too that I liked about this one is it already came with the auto bed leveling sensor included. This model has the BL Touch. They made some other previous models that had a capacitive touch sensor, but I guess Creality decided that, hey, you know, the capacitive touch sensor was running into problems with humidity and differences in the conditions of the room would affect how it would read the distance between the nozzle and the print bed. So they decided to go with a BL Touch version. So thankfully, that's the one that I got. Um, Another thing too is these 3D printers, for the most part, can be very noisy because of the stepper motors. They'll make a high-pitched whining that changes in pitch, and these things normally run for several hours at a time. And if you have something like this that's making a bunch of high-pitched noises in the area where you live, it can get very annoying. The fans are also very loud on all these 3D printers, including this one. And it was one of the first things that I changed. So let's talk about another part of it, which was the build plate. Okay, so the original Creality build plate was this one. So it's a aluminum sheet. And one thing that I will tell you about this particular model and my sheet is that this aluminum sheet is perfectly flat. You can check it with a straight edge on both sides, diagonally across the middle, and it's just perfectly flat. There's no gaps underneath. It's not bent in any way. So I really appreciated that. What I did not like is that this surface that Creality includes with this model grips the material so well that I actually had a very hard time getting it off the bed. you wind up having to chisel and scrape at this thing and try to hit it with a plastic mallet to get these things off. And most of the time, you wind up damaging the 3D printed part that you spent so much time printing, because it just will not come off the bed. As you can see, I got scratch marks on this from me digging into this with these scraper that they include. So I was not happy about this part of it. One thing that I did find early on is that there's a company called Wham Bam that makes a flexible print surface, which is what I have installed on this CR10S Pro V2. And what it is a magnetic sheet that has a 3M backing that sticks directly on the heat bed. And then this top sheet is a piece of stainless steel that has a PEX plastic layer on it. And the PEX is actually what grabs the material. What you do is you scuff this up with a Brillo pad, clean it with some alcohol, and then lay down your filament directly on it as the 3D printer is going. If you do run into problems with bed adhesion, one thing that I find that works very well is some Elmer's stick glue. This one is the purple one. The white one, they say, works much better, but I've had great success with this purple one. And what I'll do is, after the nozzle is preheated and the bed is preheated, right before the print starts, I'll go ahead and lay a layer down where the print is going to happen on the print bed. And then the printer will go through its auto bed leveling routine, and by the time it gets to actually printing the product, the glue is perfectly set, and it's not too dry, but it's not too wet. It's at the perfect consistency to accept the filament. So we'll grab the filament really well, and then once the 3D print is complete and the bed has cooled down, with just the minimal amount of effort, the part will come off. If the part does not come off, you could always rely on the flexible print surface and just break it away. Just give it a bend and it pops right off. A couple of things that I had to do with this unit early on is the way that the filament is fed. It comes directly from the spool holder at the top right into this filament sensor. And it comes in at the wrong angle and starts to scrape at the filament as it's entering this filament sensor. And that's not good, because you run into problems feeding it. You gouge, you mess up the filament as it's going in. It starts to deposit residue all over this area. And thankfully, you can go on Thingiverse, and they have a lot of resource STL files free of charge that you can download. Of course, the creators always appreciate a tip. So if you are going to be downloading on a regular basis from certain creators, it would be advisable to leave them a small thank you tip. And this particular thing just clips on the side. It uses a standard roller skate bearing. There's a little pin that goes in here, and then your other parts are 3D printed. They just snap in, and then your filament rides down along here, giving it a softer angle to enter that filament sensor. Up at the top, let's see if you guys can see the top. I'm going to tilt this to the top so you guys can see maybe. Okay, up at the top, there's another bracket that was also 3D printed. Again, this is from Thingiverse, and I'll include links to all of these files in case you guys decide to get a CR10S Pro. You guys will know all of the little parts that have helped me. You can print these out yourselves, and they make a big difference. Let me go back down to the machine itself. All right. A couple of things right off the bat that you'll notice if you're going to purchase a CR10S Pro is it comes with a very good parts cooling fan. And this is important because as it's laying down the filament, that hot plastic, if you can solidify it really, really fast, you're not going to get any sagging or any problems with your print. If you print at too hot a temperature and you don't have a good cooling fan, what happens is your print will get distorted. The disadvantages to printing at a low temperature is you don't get good layer adhesion. So what you'll find is your prints are brittle. They're easy to break, and usually they break right at the seams where the two pieces of filament meet, because it wasn't significantly melted to fuse those two layers of filament together. So parts cooling fan makes a big difference. However, the Creality duct that they provide with the fan is inadequate, completely inadequate. It does not blow directly on the nozzle, and it blows with such force that it causes a lot of stringing and doesn't do a very good job at all at cooling the filament. One of the first things that I did is I looked for a replacement for this duct and was unsuccessful in finding a simple design like this that could easily go in place of the original one. All the ones that I found were very elaborate. They involved replacing the entire hot end cover, and I didn't want to get into all that because this hot end cover works really well. The fans bolt up to it really nice, and this was really the only part that I needed. So what I decided to do was I took measurements off this part and just created my own version of it. So this is one of the prototypes. It has a gap over here. I since fixed that, and I have the upgraded version on the machine now. And this gives me two different points that air blows out from. So it completely surrounds the tip and cools the filament right away. As soon as it exits, it's already hardened. So that's very good that you can replace a part like this. It's essentially a freebie. I'll include an STL file free for download of this part if you guys decide to get this printer or one that has this fan style. By the way, this fan is a 4020. You can use this part. So it just fits right inside the fan, and then it has one fastening screw on the side here, and it fits really really nice. All right, one of the other things that you may want to get for your 3D printer once you start getting into this hobby is buy yourself a Raspberry Pi. So this is essentially a little tiny mini computer that boots off of a file that's kept on this SD card, and it runs a program that will allow you to communicate using your mobile device, tablet, or PC wirelessly to the printer. You can control the position of the bed, the position of the gantry, the position of the print head. You can do time-lapse recordings. You can start prints. You can move files between the computer and the 3D printer very easy without having to rely on physically putting it on the SD card and manually transferring it over. It's very convenient. I highly recommend you picking up something like this. If you decide to go with the Raspberry Pi, one of the things that I ran into at the beginning was not being aware that it needs a specific type of power supply. So even though it uses a standard mini USB power cable, you do have to have a power supply that is 2.5 amps or greater. Otherwise, the Raspberry Pi will not boot. It'll light up, you'll see the little light going, you'll think it's working, but you'll never communicate with it because it's not fully on. So make sure that you get the correct power supply. This one is by CanaKit. Again, I'll include all the links in the description. And that's also the place that I bought the Raspberry Pi from. They supply the Raspberry Pi and the power adapter. If you decide to not go with this power adapter, make sure the one you get is 2.5 amps or better. The little case that the Raspberry Pi is in, you can simply 3D print. They have plenty of different versions of it on Thingiverse. So you just download it, put your Raspberry Pi in there, put your cover on, and you can either set it somewhere near the printer, you can fasten it to the printer, screw it to the printer, or what I'm going to do next is I'm going to take apart the bottom and actually just incorporate this inside so I don't have it hanging on the outside. A couple of tools that you're going to be needing is you're going to need a stainless steel brush. So I use a stainless steel brush after every print, and typically what my process is I'll heat up the hot end to the temperature of my last print, and I'll just allow the filament to ooze out as much of it that's in there, because this thing will create some pressure as it's extruding, and once you finish your project, there's still filament in there. So what I do is I like to turn on the hot end, let it heat up, and I allow whatever filament that's in the heat break to ooze out. And once it's out, I just pick off the excess with this little tweezer, brush off the tip, and then I won't have any risk of having filament mess up my next print's first layer, because it'll be totally clean and ready to go. At that point, then what I'll do is I'll heat up the bed. So the nozzle's clean, it's already preheated. I heat up the bed, and then I'll go ahead and right before I start printing, I'll apply the Elmer's stick glue to it. I'll just put it in the area where my print's gonna go, and then start my print. And that's it. I usually get very good first layer adhesion, and I don't have any problems with that. So let me bring you in close here and show you the duct and the BL touch sensor. So here's the custom duct that I created and how it fits. You can see it bolts on the side there. Not sure if that's getting in focus yet. And it works great. You see the BL touch sensor is right here. And then I'm using a Micro Swiss all metal hot end. One of the things that early on that I discovered is after about 3 months of printing, I started to run into issues with the filament jamming inside the Bowden tube. And this little blue line right here is a Bowden tube. I upgraded this also as well. This is a Capricorn Bowden tube. It's got a very slick surface to it and has better temperature resistance to the metal hot end. So you're not going to have any problems with your tube melting inside the hot end and causing problems. However, the problems that I was having was where the Capricorn tube met with the hot end. And there's a gentleman called Chuck that has a great YouTube channel. It's called Chep, and I will include a link to his channel. He's got great tips and tricks on adjustments and things that you can make to your 3D printer to improve the print quality significantly. And one of the tips that ran into from his channel was creating a part to exert pressure on a section of Bowden tube that is down inside the hot end. So I'll put a link to that video. If you guys are having any problems with your hot end getting backed up and stuck and not extruding, this will be probably the video that's going to help you resolve that issue. If you don't want to deal with having a Bowden tube backup issue with your existing setup, consider upgrading to the Micro Swiss hot end. The beauty of this hot end is the Bowden tube does not have to go down into the print head. What it does is it stops right here at the top. So it goes down about maybe ½ inch and then stops. And then the rest of the filament goes down through the aluminum heatsink. And then there is a titanium part that's called a heat break. And once it gets down through the heat break and enters the heating nozzle, that's the time that it melts. But it's not melted anywhere above the heat break or inside of the aluminum heatsink. So that's the beauty of this setup, is you don't have the possibility of that jamming up issue with the filament clogging inside the hot end. It has not happened to me since I've put this part on the 3D printer compared to the original one. So it's been working great. It also allows you to run much hotter temperatures and different types of filament, like wood filaments and carbon fiber. With this all metal hot end, provided that you change the tip. So I'm running a stainless steel tip as opposed to the brass tips that normally come with these. And let me turn the unit around so that you guys can see some of the changes that I made in the back. So this is another little upgrade that you may want to make. It's relatively simple, and it's with these springs. These are, they have a higher tension than the stock springs. And what this benefit of changing these springs out is, since they have a higher amount of tension, you're not going to get changes to your bed level as often. what happens just over time from the printer moving around and vibration is that these these um, these wheels will move around a little bit, and it'll get out of adjustment. By having more tension on it, the wheel is less likely to move out of its position, so your bed level will be maintained for a longer period of time. So again, let me give you a shot here of this dual rail system here. So you got 4 sets of wheels on this rail, 4 sets of wheels on that rail, and then the belt in the center that runs the bed forward and back. Now on the back side, I got a couple of things that I changed here. For one, we got Mr. Peanut over here. He's a free upgrade, and Mr. Peanut just gets this thing over to the side so it doesn't snag on this corner here. I may have to 3D print some kind of a little deflector here, but I noticed that this was starting to happen recently, so this is my temporary fix. So it's a little cheesy, but it gets the job done for now. Okay, so these Z-axis rods, these threaded rods, when the machine is off, these stepper motors will release their tension, and on this side especially, it will drop down a little bit, and then what happens is when you turn the machine back on, it will start from the position, from that sagged position. It won't bring it back up. So what I have here is a couple of backlash adapters. You can pick these things up on Amazon or eBay, and they're relatively inexpensive. I'll put a link to all this stuff in the description. That way you guys aren't hunting around for it. But what this is 2 separate pieces with a spring in the middle. And what it does is it creates tension on the rod to keep it from moving. Another thing too that'll help tremendously is adjusting your wheels to make sure that they're tight up against that rail. So between tightening the wheels being up against the rail properly, and this backlash adapter on both sides, because I got the backlash adapter also on this side, but since it's behind this cover, you can't see it. That keeps this gantry and these and the position from moving, whether the stepper motors are on or off. So that's a huge benefit, a big upgrade that made a big difference. And the reason that you want to do this is if your gantry is not level, your prints are going to be thrown off. And you don't want that. Even though this does have an auto bed leveling feature, you want your gantry to be level. Otherwise, you're going to get inconsistent prints. So what else can I tell you about the backside? Oh yeah, okay, I can see here the Noctua fans. When you first purchase this printer, the fans are loud. It does have a silent motherboard, which is another reason why you want a printer like this that comes with a silent motherboard. This one, the Ender 3 version 2, also has the silent motherboard. And that is a tremendous improvement because the stepper motors otherwise make all kinds of whining noise that will drive you crazy. And that silent motherboard makes these things, you don't hear them at all. They move up and down, totally silent. But what's not silent are these fans. These fans, they make a ton of noise. Creality uses a 24-volt power supply, so a lot of these fans are 24 volts. When you're changing out your fans, you have to be aware of this. You can use 2 different methods to resolve the problem. You can run the fans in series, and that will step down the voltage. So instead of them being 24 volts independently, they'll each share half the voltage, so 12 volts each. That's something that you guys can do. You can also use a little buck adapter. It's a small little board that has power in and power out with a little adjuster on it. So if you have 24 volts coming in, you can adjust it down anywhere from 24 volts, I believe, down to about 3 volts. So you can adjust it anywhere in between there. And that is another great thing that you can add to your build. I'll include links to those little buck adapters. Right now I'm using some that are super tiny. The fan on the front of the unit that cools the hot end has also been changed to a 12 volt version, and you can minimize noise on that one using the buck converter. So the buck converter allows you to turn down the voltage slightly. So instead of setting it at 12, I got mine set at 9.8. Since I do have a all metal hot end, the all metal hot end runs extremely cool. So I was able to turn down the voltage on the fan to where you don't even hear the fan hardly for the hot end. The only fan that you hear is the parts cooling fan, which needs to run at 100% to get the best quality prints. Now I'm hoping Noctua, which is the fan company that I use for the fans inside the power supply and inside the unit, I hope they come out with a 24 volt or 12 volt 40-20 style fan. If they do, I'll change mine out in a heartbeat, because that's the one thing that keeps this thing from being virtually silent. Anyway, guys, if you like the content I'm putting out, make sure to subscribe to the channel if you're new. If you are new and haven't turned on your notification bell, please do that. That will alert you to new upcoming videos. Share this video if you found it helpful. Like the video, give me a thumbs up if you found some of this information helpful. And leave me some comments. I love the comments. Again, thanks a bunch for all the support. God bless. Till next time.